So as I promised a couple of weeks ago now, I'm going to build a simple omnidirectional antenna to get me started on my software defined radio, and a few of you have asked me if I would look at this, and I did promise a couple of weeks ago when I upgraded mine to an SMA connector. So what I'm going to do is build a omnidirectional monopole that will work over quite a wide range from 900 megahertz and below, and that should you know, get me into the hobby, and you know, should be able to pick up quite a lot of traffic in that area. But I want to make it adjustable, so I can also tune it in a little bit more. If I get a decent signal, I can you know, extend and contract the monopole to try and tune it in that little bit and trying to get a better signal out of it. So this is going to be a first antenna to cover that wider range of frequency, just to get me going, so to speak. Now, I did think quite a lot of how I was going to approach this video, and it is taking me out of my own comfort zone of the microwave frequencies. So what I'm going to do in this video, I'm not going to go over any kind of theory of operation in particular. It's just the measurements, and if you copy the measurements that I use and the general build idea of this, then you should be able to come up with a similar antenna and get yourself started on the software defined radio, and certainly upgrade that piece of rubbish antenna that you tend to get with the software defined radio kit. So a couple of things that I've got here on the bench then. I've got myself an adjustable net curtain pole that I picked up off Amazon, and I will put a link to this on Amazon so you can get a good idea of what you need to look for. Just this week actually, the seller that I bought this off no longer delivers to my address here in the UK, so I don't know what's gone off there, but there's plenty of sellers that sell these, so if I put a link, you'll know exactly what you need to look out for. And this is a little bit longer than I need. This is 900 millimeters long, so it's just under a meter long, and then this bit twists, which I quite like about this design actually. Twists out to extend another 500-600 millimeters out on this end, so it's quite a long pole. But I do like the telescopic feature of this. Normally you get them where they just slide in and out, but this one twists, and I'm kind of guessing that there's a spring in this, so I'm hoping to incorporate this into the antenna, but we'll see how we get on with that. Now, the thing about these lower frequencies, the wavelengths can be massive and normally measured in lengths of football pitches, so I am going to be using this galvanized garden fence wire. It's about 3 millimeters in diameter, quite soft, easy to work with, and I'm going to be using this to build a loading coil in order to make the antenna a lot shorter in length, just like you see with those CB radio antennas that you can stick on top of cars. Without the loading coil, it would just be far too long. You'd be hitting bridges every time you go under one. So the loading coil allows the antenna to be a lot shorter and still operate in that frequency range. So I'm going to make the loading coil first. Now, what I've got here is a piece of plastic tubing, 35 millimeters in diameter. You don't have to be so precise. If you've got something around 30 millimeters, that should be fine as well. And I've drilled a little hole in the top here so I can insert the wire, so I can anchor it down while I form the coils around the former tubing here. Now, I'm going to be using a meter length of this garden wire, so I'm going to put a little blue mark where a meter ends, and I'm going to not cut that off. I'm going to hold all the excess in order for me to give something for me to grip on to form it around here. And a meter length should give me you know, more than enough length to form a nice coil, and also bend the ends as well so we can attach it to the antenna and the coax output as well. So it's just a matter of keeping it as taut as you can and just forming it around your plastic tube here, and then stopping where you've marked it off where it's a meter long. You can tidy all these coils up when you actually get it all around there and formed. So this is my coil formed, and what I'm going to do now is use about half a coil's length here, and I'm going to bend it in and then up so I can connect this to the monopole, and also connect some coax to this so we can use it as well. So about half a coil, and just bend it inwards about like that. Then I'm going to straighten this out a little bit, and then roughly in about the middle here, bend that upwards. So we've got something like that, and just straighten this out a little bit. I won't cut this off to length yet, just in case I need it all, and I can always shorten it when I'm connecting it to the monopole itself. Now, because this wire is not like sprung steel, it doesn't hold its form well when it's put under stress. So if you do bend the coil too much, it will stay in you know, around about that position. So what I've done is I've cut a piece of the tubing that I've used as the former off, and I'm going to insert that on the inside just to hold the basic form of this together. It'll still allow a little bit of movement there, and I'm going to bend the end here like I have on this end, and that'll lock this piece of tubing in place. And then I'm going to cover it all with heat shrink tubing just to tidy it all up, add a little bit more strength to the coil as well. So that's the coil finished. Still a little bit of flex allowed there, but it locks it in that shape and that position a lot better than it would if we left it exposed. And the most important thing is that none of the coils are touching, and you know, get them as evenly spaced as you can. A couple of mine are a little bit out, but that shouldn't make that much difference. The main thing is to not have any of the coils touching. So deconstructing the pole then, it's a rather ingenious design. Basically, this thicker piece here has a spring that runs all the way down the center of this, and it's attached permanently on this end here by these indentations, so it doesn't twist around inside there. And then what happens is this thinner pole here screws down onto the spring, and the spring screws up inside this thinner pole, and that's how you get the springiness and the you know, being able to telescopically make it larger or reduce its size. So I think what I'm going to do is, because I only want 600 millimeters length of this thicker piece of pole, I'm going to cut it off, measuring from this end here, and cut it off in around this area here, straight through the tubing and straight through the spring, and then I'll permanently attach the spring to this new end here. And this piece of much thinner tubing, I'll cut this off at from measuring from this end here, which is the part that screws onto the spring itself. It's got this slight indentation here, so it catches on and it acts like a thread, and cut it off around here and do away with this piece here. So I think that should work out fine, and that way I'm keeping the spring, so I'm keeping you know, the way that this operates, rather than just having it slide in and out. So both rods are cut to length now. Then I've got 600 millimeters for the wider one and 500 millimeters for the inner one. Now this is the spring that goes inside the thicker diameter tubing here, and this thinner diameter then screws, let me get the correct end, screws down onto this spring like so, and that way you can you know, operate it like you would a thread going up and down. It gives it that little bit of springiness as well. So what I'm going to have to do, because I want to make sure I've got conductivity all the way from here onto the smaller one as well, running through the center with this spring, I'm going to clean this spring up with a little bit of emery paper just on the outside, because it's got some protective type of grease on this. So I'm going to rough it up with some emery paper, and I'm also going to clean the inside, probably see on the better on the thick one, the inside of these tubes as well. I'm going to put some wire wool down in there and just pass it through on the inside a few times just to clean it up, get rid of any kind of grease on there, just to make sure that we've got good conductivity running throughout the monopole antenna here. So I've cleaned the spring, the outer edge of the spring now, so we've got good connectivity with that. I've also cleaned the inside of the tubing with some wire wool. You know, probably what it's like to clean the inside of a barrel of a gun, but you know, I've never cleaned the inside of a barrel of a gun, but just stuck it through a few times and it's done the trick. But what I'm doing now is I'm figuring out how I'm going to connect all this to the loading coil. So what I've got here is a small piece of brass tubing, and what we can do is create a solder cup to solder this piece of the wire onto the inside of this brass tubing, and I'm going to attach solder on this brass tubing to the inside of the spring, and to make up the diameter I'm just going to wrap some solder wick around there and flood it all with some solder, and then clean the inside of the spring in this area here, and then flood all that with solder, and hopefully we'll have a good connection there with this little solder cup. I can remove the coil like so, have a little bit of this sticking out, and then just get in there with my soldering iron and attach permanently the loading coil to the antenna then. So I think that's going to work out pretty well. So I've got the little brass tube soldered in place then, and you can see just on the end of this wider tube in here, I've got it with a soldering iron and just put some tin of solder around the edge of there. And what I'm going to do now is build up the sides of this spring with some of the solder wick, flood some solder in there, and then hopefully I'll be able to flood solder all around here and attach this in place permanently. So you can see here I've wrapped the solder wick around and just attached it in place with a little bit of solder. It just fits nicely into the end of this tubing now, and because I've already pre-tinned just inside the tube here, I'll just flood a bit more solder onto this solder wick, heat it up with my soldering iron, and get all that solder to flow, and it should attach itself then to this tubing here, and we'll have a good electrical connection then with the rest of the tubing and also the spring inside this tube as well. So you can see what I've done there. I've just flooded solder in there, and you know, basically now it's not going to go anywhere. The spring and the little brass tubing that we're going to use as a solder pot is in there really firmly. It's not going to go anywhere anytime soon, and of course it's conductively connected to the rest of the antenna. So what I'm going to be doing now is soldering this end of the loading coil onto here, just as I said, use it as a solder pot, and I'm going to cut this end down here, and I'm going to be soldering that to this BNC connector I've got here in this project box. Basically you can use any kind of project box like this as a base. This is one that I picked up from a Hamfest a year or so ago now. It's got a hole in the side and there was an end connector on there, but I used that quite a long time ago in a different project. But I've basically just drilled a hole through the top here. Going to put some heat shrink tubing around here as well, so it doesn't come into contact with this and short itself out, because this is going to basically be grounded by the outside of this BNC connector. And then we've got the main connection here to the monopole antenna soldered onto here, and hopefully then we've got a working antenna. So basically simple, just solder everything in place, and we're going to have the loading coil on top. I'm also going to add some epoxy to the base as well, just to fix it down onto this project box. So I've got the antenna attached, as you can see here, but it's a little bit wibbly wobbly. So what I'm going to do is get some heat shrink tubing and make a boot in this area here, just to give it a little bit more strength, just so it doesn't wave around so much, especially when I'm adjusting the length of this, just to give it a bit more strength as well. So a couple of different diameters of heat shrink tubing. I'll make myself a boot to fit on top of there. So to do this, I've put some wider heat shrink tubing here around here to create the boot, but you can see because it's such wide heat shrink tubing, it doesn't quite grab the main body of the antenna. So what I've got here is some narrower stuff that I'm going to fit over the top of that and over the top of this wider heat shrink tubing, just to nip it all in and then grab the main mast of the antenna. That should give it a lot more stability. So here's a look at the finished antenna then. You can see the boot at the bottom there. It's done a lot to help stabilize the antenna itself, but I've got it set on its lowest setting, but I really do like it, especially the adjustment you can do to make the antenna longer or smaller. So I've got some 75 ohm coax there, so let's hook it up to the spectrum analyzer and see what kind of frequency range this will cover. So I've currently got it set up just you know, how I would normally to test an antenna, but I've got some different equipment here because it is such a lower frequency, but basically everything's the same as you would for the higher frequencies. Now I'm going to be testing this. I'm going to need access to the spectrum analyzer to change you know, the settings on the spectrum analyzer so we can see how well it's performing overall. So I'm going to need to put my camera on the camera arm up there, where normally I just use the tripod, so I can work underneath it. But you can see here, that's the antenna under test. I've got it on its shortest setting at the moment, and I'm not going to be able to get that in shot at the same time, but we can work through on the spectrum analyzer and see how well you know, it performs from you know, up to 1 gigahertz. So you know, let's have a look at it, and I'll talk you through. And I can already see on the spectrum analyzer we're getting 3 good frequency responses already with the antenna at its shortest position. So let's start off then. I've got the antenna on its shortest setting, and you can see here on the spectrum analyzer I've got the spectrum analyzer set up from 10 megahertz up to 1.1 gigahertz. So this is the area in which we're interested in, up to 1 gigahertz. I've got the spectrum analyzer centered on 400 megahertz, and you can see here on this line we've got a pretty good frequency response right there. We've also got another good one here, and then a third good one just here. So let me just zoom in on this one first, and we'll see how good it really is. Now, one thing to note is, because I'm only making this antenna for receiving only, we don't have to worry too much about a decent VSWR. We're just seeing, you know, what kind of frequencies you get the best response on. So let me zoom in a little bit. You can see here, this is the very good frequency response here. We've got a nice dip just here, but basically anywhere in this area is going to work really nice. So that's basically virtually bang on for 388 megahertz, but as I said, anywhere in that area is going to work pretty nice. So we'll take a look at the second one then. So we'll go up a little bit. Zoom in. Go the right way. So again there we've got a pretty good frequency response there at 569 megahertz. So again, that's another good frequency response. Let's zoom out and take a look at that third one. You can see here that that's the end of the spectrum there. That's the cutoff at 1.1 gigahertz. So let's zoom in at this third frequency response. And again, the third one is not as quite as good as the previous two at 700 megahertz there, but you know, it should work fine for receiving. As I said, you don't have to worry too much about the VSWR. So I've moved that back a little bit now then, so let's extend the antenna to around half of the height that it can go to, and we'll take another closer look at the spectrum and see where things have shifted a little bit. So now that it's settled down a little bit, we've definitely changed things. We've definitely got 3 frequency responses, one there, and one there. And we seem to have a little one down here now, which would make sense because we've extended the length of the antenna. So let's have a look at this first one down here first. So maybe not as pronounced as it first looked like it was, but certainly we've got some little dips in this area here. So let me shift it up a little bit and see what else we've got. So this frequency response here is around the 400 megahertz. That was the first frequency response we just looked at, but you can see it's certainly changed a little bit, extending the antenna. We're definitely getting more responses this way. It hasn't been quite so pronounced as of a dip in this area here, so extending that antenna has changed it a little bit. So this frequency response is at 573 megahertz. So let's zoom in a little bit on that one. You can see that is a quite a nice response there. So let's go up the spectrum a little bit. And we're getting a nice response there. Let's just see exactly where that is. So that's around the 700 megahertz mark. Zoom out a little bit to get our bearings. And we've got a few responses here towards the end of the spectrum as well. So let me extend it out now to its maximum and see how that changes. But what I'm going to do, I'm going to center this spectrum analyzer on this area here where we've got that nice dip and see if that changes any. So let's see what happens to this frequency response when I extend the antenna to its maximum. So it's certainly changed the frequency in this area here. So let's just zoom out, take a look at the full spectrum. And I'm seeing 1, 2, 3, 4 good frequency responses there. This really nice one down here now that we never had before, now it's fully extended. So let's zoom in on that one. So that's around the 400 megahertz area that, you know, the frequency response was there when we had it at its minimum. But let's zoom in. So that's a really nice response there. That is actually a classic pattern for a very nice broadband frequency response there. So it's working really well in this area with the antenna fully extended. That's a much better frequency response and possibly a very good VSWR as well in this area. But as I said, you don't have to worry too much about that when you're only receiving. So this is the full spectrum then, from 10 megahertz up to 1 gigahertz. You can see we've got some very nice frequency responses, 1, 2, 3 and 4 there. Extending the antenna out does make a difference. Wasn't quite the difference I was looking for, but certainly you know, you can tune the antenna. If you do pick up a signal and you know, it's a little bit faint or a little bit noisy, you could possibly you know, extend and contract this antenna to see if you can tune in a little bit more to that you know, frequency you're trying to pick up. So I think certainly for a software defined radio, to have an antenna that you can tune by you know, making it bigger or smaller would definitely be a benefit. And for a first build, this isn't too bad at all. I think we can definitely improve on this, and certainly having the wider bore tubing does extend the broadband of the antenna, you know, when the frequencies that it covers, and that's what we want. We want an antenna that can work over much broader frequencies, rather than putting just selective antennas in there just to you know, you're not going to pick much up if it's too much of a selective antenna. So for an antenna that will work in this spectrum quite well to get you up and running, this design isn't too bad at all. So I hope you enjoyed this video. It was a video that one of my subscribers asked if I'd take a look at, and a few of you also seem to be interested in this, and as I said, it's something that I'm looking to get into as well, but I'm just starting out with this software defined radio stuff. But again, we can look at some more antennas. We can look at going from 1 GHz up to 2 GHz, or possibly 1 GHz up to 1.5 GHz. Not sure whether that might be too much of a jump, but we can definitely look at this kind of design again for the higher frequencies, and it should be interesting. But you know, hopefully you did enjoy the video and you got some ideas out of it. If you did, please give it a thumbs up, and any comments from people who've been doing this for a while, this software defined radio stuff, any ideas that you've got, you know, that from your experience of doing this that I could possibly build, or you want to take a look at, then please feel free to drop a comment below. But if you did enjoy it, please give it a thumbs up, and hopefully you'll join me on the next one.